to our ASCE 7-16 webinar on adhered installs. So guys, before we start again, kind of wanted to share a couple things with you guys. Please, we're going to show you some stuff here and might blow your mind a little bit. So just remember, this is not something that GAF came up with, right? It's not something we designed. It's an industry standard thing that's either already happening in your state or it might be in the pipeline. So please don't kill the messenger. But like yesterday, we will sacrifice Stephen McCabe.
Yeah, because he will fall on the sword for us.
Yes. So, and then another thing, guys, we're gonna do like a 10,000-foot view on our on the webinar today again for the ASCE 7-16. Our goal here is just to give you enough information to help you guys out when you're on a project when this pops its pretty little head, that your head's not blown up or you're caught off guard, where you have some information, some knowledge of it. But if you guys need more assistance or more resources, please contact GAF Tech Support. They'll be able to provide you with anything you probably need. Also, look out for future webinars that actually will get into the meat of the code to help you guys out a little bit more. And also, Mr. McCabe already put a link in the chat box. This is a link that I recommend you guys download it. All right, this is a PDF here. It's like a 61-page PDF. It's pretty much the guide to using ASCE 7-16 for EverGuard, TPO, and PVC roof systems. And then the last thing, Wally, right, is here on the care team, once again, we try to give you as much knowledge as we can so you guys can take it to the field and help you guys out with installing the roofs. But with the ASCE 7-16, there's so many variables, too many things that come in to let you know how many fasteners per board or how many perimeter sheets or how big your sheets are, right, or your perimeter, right? So we can't really give you that information. You know, there's no carbon copy or a template we could hand to you, but we are going to give you some resources that you could use that's going to help you pretty much design that roof for you that Mrs. Joan Crow is going to add you.
She's a lot smarter.
Lot smarter. So, with no further ado, guys, I would love to introduce again Mr. Wally Brown, a guy that I consider the encyclopedia of roofing. Hard worker and a guy that I've actually had the pleasure to work with for the past year.
Yeah, all year.
He had beautiful black hair, and now it's all white. I don't know. I've been a joy to work with, but apparently not. And also behind my other partner in crime is Mr. Stephen McCabe. And guys, Mr. Stephen McCabe is by far one of the hardest working guys. You know, he does everything to set up all these webinars. Does a great job of doing these presentations and whatnot. So we'd like to just do Mr. Stephen McCabe.
Because those guys wouldn't want us doing the computer stuff.
No. Copy and paste means a lot different for us.
Construction paper almost.
Go ahead, Stephen.
Hey, thank you, Chino. Thank you, Wally. I appreciate, just throwing the darts at me. And, I'm hard pressed to decide who I feel worse for, whether it's Chino or Wally, that you guys have to spend a whole year together. But with that said, I would be remiss because Chino is humble. He doesn't want to introduce himself, but Chino is a guy who has a tremendous amount of experience, especially in the field. He was an installer, a foreman. He managed multiple crews. And then when he first joined GAF, he was an inspector. So he's got to see basically the good, the bad, the ugly when it comes to installing commercial projects. And the last couple of years, I've had the privilege to work with him. So I can say honestly that I've learned from him. So it's great to have you with us today, Chino.
Thank you, brother.
So let's start about with ASCE 7-16. So to give you a little background, ASCE 7 is like Chino mentioned, it's a standard. It's not GAF. We're not part of it. We're just here to kind of let you know what some of the changes are taking place. Please don't shoot the messenger. This is not GAF's baby. So to give you an idea is that we're all familiar with the International Building Code on the commercial side. That is created by ICC, the International Code Council, and then eventually it's adopted either by the state and local municipalities. Well, from there, the IBC has adopted the ASCE 7 throughout the years. And so you can see in 2006, they adopted ASCE 7-05. 2012, they adopted ASCE 7-10. Well, the latest one, IBC 2018, they adopted ASCE 7-16. So you can see the evolution. Now, the states that have adopted it already are the states with the blue. So as you can see here in the blue, you have the Southeast, you have South Carolina, Georgia, Florida, Mississippi. You have some in the mountain states and the Pacific West. You also have in the Northeast, New York, New Jersey, and Maryland. So these are the states that have adopted ASCE 7-16 already. Now, with that said, though, is just with code is there are those states that have adopted it at the state level, but then there are some states like the state where Chino and Wally are right now, they don't actually have a state code when it comes to commercial. So all of their counties or their cities, local municipalities are the ones that are adopting things at an individual basis. So you have to be aware of your local code to know if those places, if they've adopted ASCE 7-16 or not. So for example, in Texas, I heard Houston has adopted ASCE 7-16, but as you can see, the state of Texas has not because they don't have a state code. Now, in addition, is even if your state has a state code, remember that just becomes the minimum, and any local municipality can always add it to it or make it more stringent. So keep that in mind. You really need to know your code, local code, what has been adopted and what has not. So when we go to what ASCE and some of their design requirements are, when ASCE 705 was around, it was looking at one wind speed map based on the allowable stress design. Well, ASCE 7-10 upped the ante to the ultimate design and risk category, and they divided it between 3 different wind speed maps. And now ASCE 7-16 is based on 4 wind speed maps. Now, you may ask me, what are those wind speed maps? Well, it's based on the category of the building or the risk category. So type 1 is for farm animals and sheds and that type of thing where loss of life is to a minimum. And so what I want to do is, I know everybody's from different places across the country, but easiest thing to look at and to hone in on is that 170 miles per hour over at Miami. Okay, so roughly in that vicinity, Category 1 buildings will have 170 miles per hour wind. Now, if we go to a Category 2 building, you can see that southern Florida now goes up to 180 miles per hour. Now, risk Category 2 deals with basically your standard commercial building, your banks, your gas station, your stores, your Walgreens, whatever, your basic commercial building will fall into risk Category 2. Now, they up the ante again to risk Category 3 because now we're dealing with, let's say, maybe a school or a university. You're going to have a lot of people in that vicinity at that one time. And now you can see southern Florida jumps from 180 to 200 miles per hour. Finally, the last building is the Category 4 building. That has to do with loss of life. So, maybe an emergency shelter or police or fire or a hospital. They may be designed around that Category 4. So you got to realize what your risk category is when you're determining this ASCE 7. Now, so we got part of the design. Now, let's go back to ASCE 7-05 and ASCE 7-10. And Chino, I know you guys are great at it. Can you kind of spin us up to what the existing is, or at least what we're more used to, shall we say?
Yes, please. So everyone, once again, we're that's what we're used to is dealing with 7-10, right? McCabe, are you going to be able to jump over to the other screen, brother? Or no, the other slide?
Yes.
We got to retrain him
Every time, man. Every time.
Is he off mute?
Are you off mute, McCabe?
So,
yeah.
Which camera are you on? I see like half of you, man. I mean,
I'm right here.
Okay. There
I'm only 5'5", man. Come on.
5'5".
So I gotta help out Wally here because if not, he's out of it. So, So hold up. So guys, we're gonna go back to our 7-5 and 7-10, right? So right now, what we're showing you is the attachment table for an ISO board, right? And once again, GAF kind of helps you out with this. It's in our spec books, where depending on the thickness of an ISO board is going to determine how many fasteners per board. So, for example, our 4x8 2-inch ISO, we have 8 fasteners per board in the field, 12 in the perimeter, and 16 in the corner. Now, each time the ISO board gets thinner, it starts getting a little bit more aggressive on the screws, right? So as you can see at 1 inch, we're at 16, 24, and 32 fasteners per board on a 4x8 sheet. Once again, we give you somewhat the numbers that you need, but we don't give you the number on how wide your perimeter is supposed to be. So that's what Mr. McCabe is going to show you here next, is kind of the equation that we used to deal with. So once again, like I always like showing people, is our roofs are in 3 zones, right? Which is zone 1, our field, zone 2, our perimeter, and zone 3, our corner. And as you guys can see, our corner here is square. That's one of the big changes with ASCE 7-6, 16. I'm sorry. This is the one of the main difference. As you guys can see here, it actually lines up perfectly with our perimeter. But now, how do we come up with our perimeter size? As you can see right next to it is the formula calculation, right? Where we got to multiply 0.1 times the building width or 0.4 times the building height. And whichever number is smaller, that's the number we're going to go to do our perimeter, right? Now, this is just a little bit different. If our equation comes out in inches as well, Wally, right? We snap a line on our ISO board. That's going to be our perimeter. Where in at half sheets, we actually got to go up to round it up to the higher number. So, for example, right here on our ASCE 7-10, and once again, if you guys read the bottom print on there, this is only based on the height of the building, not the width. Okay, so with 7-10, a building that's 41 feet high, our perimeter is 16 feet 4 inches, right? Now for ASCE 7-16, for that same building, 41 feet, we're at 25 feet high.
25 feet wide.
Wide, I'm sorry, 25 feet wide. So once again, guys, do not kill the messenger on this, because yes, our perimeter got way bigger. It's going to need a lot more fasteners, especially for an adhered system, right? And a lot more labor, right? And that's, once again, Wally and myself, where we were contractors, this stuff right here is a killer, right? This is where, like, oh my God, now I got to put more money in for my bid because labor.
And you guys are installers in the audience. You guys are looking at this going, holy crap. But again, we didn't come up with this. And, you know, roofs weren't blowing off. I mean, if roof was blowing, it mainly from an installation issue. So,
but Mr. McCabe, can you do me a favor? What about buildings that are less than 60, I mean, greater than 60 feet high? Can you explain that to us, please?
Yeah, so if it's greater than 60 feet, then we're actually going to revert back to the ASCE 7-10 calculation. So either 10% of the building width or 40% of the height. But be aware, though, is your uplift pressures that you're going to have to meet are going to be much, much higher, though, in that situation. So once again, we are going to be, you know, it would be great, and we would love nothing more than to say, hey, in this situation, you're going to have this amount of fasteners, and this is what your perimeters and corners, and spell out everything. But unfortunately, you're going to have either an engineer or the specifier is going to have to run those calcs for us for those uplifts. So we'll give you some examples later on, but just be cognizant. Greater than 60 feet tall building, we're going to go back to the 10% of the width, 40% of the height, but your uplift pressures just went up.
So Steve, when you say uplift pressures just went up, so basically what you're telling the guy in the field is you're going to need your fastener spacing could or could not be more dense, correct?
That's correct. So more fasteners, most likely.
And correct me if I'm wrong here. So any given building, doesn't matter what it is, what size, there's basically 2 equations you need and 7 or 8 different variables you have to figure in to get these pressures, correct?
That's right. So that's way beyond me. I don't know about you, Wally.
That's over my head. I know it's over Gino's head because I'm about 2 foot taller.
So here is Chino again when he first saw it, and he is just, it's blowing our mind, right? So with that said, though, is formula calculation. So if you know the formula for the layout, you're going to be at least ahead of your game, and we're going to pound this. And if you saw this yesterday, you're probably already familiar with it, but we're going to be tackling it from the adhered perspective today. Is the formula calculations is 0.6 of the height for the length of the zone 3 or the corner, and 0.2 of the height is going to be the width of the corner or the zone 3. So as you can see here in the diagram, you can see it in the upper right hand side that's our 0.6 of the height, 0.2 of the height. Now when we go to zone 2, it's going to be 0.6 of the height. So as you can see here, it's going to step in 0.6 of the height. That's how far we go, and that's going to be our perimeter. Then we have 0.6 of the height again for zone 1. Okay, so if we're used to the perimeter, the corner, and the field, well, we're kind of used to that already. But introducing the ASCE 7-16 is what we're calling the zone 1 prime, which is whatever is left. So after we determine the corner, the perimeter, the interior field, whatever's left at that 1 prime, okay, this is potentially, if it's a large enough building, the calculations may go down where our attachment's actually less than that. But don't quote me on that, because that's on a job-by-job basis, and it's also going to be large enough. Now, Chino, we love repetition, right? And I know you're really good at repetition. So could you kind of go over with us right now, that whole formula again, and give us an example?
So, Stephen, like you just said it before you started doing this, was repetition with these things. I know I see some names that I recognize from yesterday, but once again, we've been doing this for a couple months, Wally.
Yeah, trying to get our head wrapped around this, just to make it easier to explain.
Yeah, so we constantly go over it again and again and again, and trust me, especially when you start throwing different sized buildings, you got to keep using it, and especially if there's guys out in the field that are on this, installers, just repetition. So I'm probably going to sound like a broken record, but it's for the good, for the, what is it? For the better, right? For gooder. I was going to say gooder, right? It's for the best, right? So now, once again, Mr. McCabe, I'm trying to get the length of my L shape, right? So guys in the class who was participating, please put it in the chat box. I want you guys to do this with me. So I'm trying to get the length of my L shape from the corner. So McCabe actually showed you the equation. So if you guys were paying attention, I hope you guys got it. What do I got to multiply? What's my equation to get the length of my L shape? You guys please put it in the chat box.
Uh-oh. No answers yet, Chino. We might have confuse them.
He does that.
I usually do that. So, guys, for my equation, once again, anybody, especially if you guys were here yesterday, if we could throw something in, they remember?
There we go. Greg Nelson. Very good.
Greg Nelson. Awesome. So,
the
guys.
Question mark. He was like 0.6.
So, awesome, Greg. So, yes. So, I'm going to multiply 0.6 times my building height, right? Now, to get the width of my L shape, to see how wide my L shape is going to be. Does anybody know the equation for that? What am I going to multiply that?
Come on, Greg, you're on a roll.
Point two.
0.2.
0.2 with the building height. Awesome.
So, Chino, the building height. What about the building width? Is that coming into play at all?
No, not with 7-16. The width does not come involved in this anymore. It's only the height. Yeah, not anymore. It's only the height. So if we're going with our equation now, once again, zone 2. What's the equation for our zone 2, everyone? 0.6. Awesome. Now we're going in to zone 1, our exterior zone. What's our equation for there? Silence. It's killing me.
Just told you.
It's 0.6, guys. Same thing as our zone 2. Our zone 1 is going to be 0.6. Now, is there an equation, guys, for my zone 1 prime for the interior? Yes or no?
Got 50-50 shot here. No, very good.
Very good. Whatever's left over.
Whatever's left over.
So now, once again, it's really hard for me to start doing this stuff where someone's telling me. So it's easier for me just to do it. So I'm going to need your help, guys, on how to pretty much get the dimensions that we need here. So once again, I want the length of my L shape. Someone could give me the math equation and the answer. Go ahead and put it in that chat box.
And whoever gets it right, Gino has a very good expense account. He'll take you to lunch.
I was going to actually give up Eddie as a labor.
And we'll give him Eddie's later, yeah.
Anybody, guys, anything out there, McCabe?
Not yet. Oh, Ron is coming in. Oh, it's coming in hot now. So we got 30 times 6, 18. Anton is saying 125 times 0.06.
Okay, so now real quick, Eddie, Wally, can you close that real quick so I can see the screen? So, this is where everything is confusing. Remember, we eliminate doing the equation for the length now. It's only the height of the building, right? So we got to multiply 0.6 with only the height, which is 30 feet. All right? So now we're at 18 feet. That's what the length of my L shape is going to be at each direction along my wall or the roof edge. Now, once again, I want the width. I need the width of my L shape. Once again, can you guys put the equation on in the chat box and also give me the answer? I know we're giving you guys schoolwork here, guys, but just helps you guys out. Yep, got it.
There you go.
Yep. So once again, guys, we're going to multiply the perimeter, right? The 0.2 times the building height, which is 6 feet. So my L shape is going to be 18 feet long by 6 feet wide. So we already got our corner. We tackled that. Now we want to tackle our zone 2. So go ahead and do the equation again for our zone 2. Put that in the chat box. Beautiful.
They're nailing it.
They're nailing it. Awesome.
Hey, they're buying a lot of lunches. Eddie's going to be tired.
Eddie's going to be tired. He's going to be the labor. So once again, guys, 0.6 times the height is 18 feet. So, Mr. McCabe, before we move forward, I kind of want to show these guys what makes this easier for me. If you guys see the length of our L shape, right? It matches up with the inside of zone 2, right? So this is one way to line it up. Granted, I would always ask my guys to do the math, because if I'm doing a project and for some reason my L shape is either shorter than my zone 2 or longer, something went wrong, we did the math equation wrong, we might want to tackle it, take a look at it one more time. So, but that's one way you guys can figure it out if you guys are on money, all right? So now let's go with zone 1, which is the exterior field. Please give me my math equation and give me my answer.
So it looks like Chris does not want Eddie as a laborer. He wants lunch from you, Gina.
Oh, that'll work.
That would work. I wouldn't want to have Eddie either, man. Have you seen him work? Holy cow. So we got anything, Mr. McCabe, for the equation for our zone 1 exterior?
Not yet. I think everybody's distracted about lunch, man.
Good job, Wally. All right, guys. Same thing with our zone 1. It's just going to be like our zone 2. We're going to multiply 0.6 times the building height, which is giving us our 18 feet. There you go. And then, guys, whatever's left over is it is what it is. It's our zone 1 prime, which could be huge, or like the mock-ups that we have that we're going to show today, Wally. Actually, the zone 1 doesn't exist.
Exactly.
Well, actually, it does exist, but the reason I took it out is because it was so small.
It makes sense.
It didn't make sense to try to figure that out.
Just so you guys understand this, for your fastening pattern too, your fasteners are going to be more denser in zone 2, a little less denser in zone 1, and in prime they're going to be even less. So where that's going to come into play is if you're bidding a job, I don't know, take any job, you're going to have less fasteners as you're going to have more fasteners as you work out towards the edge of the building.
And once again, guys, that's where that engineer or the designer comes in to help you out with those numbers. Something that we would love to help you with, but every building's different. So I hope you guys understand it. I hope I didn't confuse you guys. And if I did, I think I did my job, right? Because we were confused.
I blame it on Steven.
Steven, yeah. Steve. Or Eddie. Eddie, shut up. Let's just blame Eddie. All right, Steven.
Well, hey, if there's a lot more screws and plates being used with this because our zones are bigger. But now, with that said, there is a ray of light. So, Wally, you were going to talk to us about Parapet Walls, I believe, because that's our ray of light.
Right. So, if you guys remember in our previous 7-10, when we talked about Parapet Walls, it didn't matter if you had a parapet wall, what size it is. It didn't matter. You still had to have perimeter enhancement around that building.
For zone 3.
So, in zone 3, I'm sorry. So, the light at the end of the tunnel is, let's say this building here, it might be hard to see, but let's say this building has parapet wall less than 3 feet all the way around it. I'm sorry, greater than 3 feet. I keep saying less than. All the way around it, we have a drip edge or a gutter at one end of this building. So wherever that parapet wall is, we just eliminated zone 3. We do not need it. Now, at the other end of this building, where we have their drip edge, just Steve's going to draw it in here, I believe. At the end of this building, we have a gutter edge. We don't have that parapet wall. We will need that zone 3 at each end of each corner of that building. Oh,
You pulled out a eraser?
Oh, check him
Man.
out. This is why we don't do the computer stuff, because I would draw actually on the screen.
On the screen.
So there's my gutter edge, my drip edge, if you will, whatever you have there. And we have parapet walls around the 3 other sides of this building. So in these 2 corners on the blue area right here, this is where we're going to need that L shape. Hopefully this makes sense to you guys in the audience.
And the only reason we don't need it, once again, like Wally was saying on the top, is because the walls are greater than 3 feet high. So once again, for us, Wally, as installers, this is a ray of light because I don't have to add extra fasteners in those corners or try to get that measurement out, right? So only thing I have to worry about is the bottom. But at the same time, Wally, what do we always tell our guys? Whenever in doubt, just go ahead and install them.
That's true, because you guys, I'm sure there's people in the audience that have been bitten down the road somewhere where they forgot to do a corner. Again, it's entirely up to you. If you're not sure, my best advice is just put them in.
Well, you got to also understand, not trying to poke at anybody, but if you got a building inspector, he doesn't know it. He just knows there's an L shape. He's going to ask, where's your L shape?
Yeah, exactly.
And not knowing that we don't need them there.
Yeah.
That's where we have our headache, guys, that we just got to make sure that we are understanding it, but there's people that are going to be inspecting our roofs that might not.
Exactly.
Right? So go ahead, Steven. Sorry about that.
So what we're looking at is obviously that is some good news, is that we can get away with some locations. If that parapet wall is less than 3 feet, we can get away with some of the zone 3. But we also have to understand is that 1 and 1 prime may change based on the size of the job. So in this example, we're going to be looking at is the building size for all 3 buildings we're looking at is going to be 100 foot by 200 feet. But what we're going to do is we're going to vary the height of the building. So from 30 feet to 45 feet and finally to 60 feet. So as you can see here, This is basically the same roof example we've been looking at. So you have the 18 feet by 6 feet zone 3, right? Zone 2 is going in 18 feet. Your zone 1 is going in 18 feet. And then you have 1 prime, which is everything else, right? So now if we go up to 45 feet in height, though, look at, we eliminated our zone 1 prime, okay? Because, you know, if we take 45 feet and we take 0.6 of that, it comes out to be 27 feet. So now our corner and our perimeters have gotten larger because of the height of the building. Now, if we get to 60 feet, see what happens is now that zone 1 is really small and your zone 2 and your zone 3 are even bigger. Remember, these are all the same dimensions, so it's 100 feet by 200 feet, but just by changing the height, we're changing how large our zone 3 and zone 2 are. Okay? Now, conversely, we're going to look at it from the opposite perspective. So, wonder if we keep a 30-foot high building, okay, and now we're going to change the width of the building from 100 feet to 60 feet to 30 feet. And with that said, our first one is, you can see, once again, it's pretty much the same exact example we're looking at. Is 18 foot by 6 feet is our corner, 18 foot in is our zone 2, 18 foot in from there is zone 1, and then everything else. So everything's kind of the same that we've been looking at, but now we're going to go to the 60 foot wide, and now what's happening is it's eating up that zone 1 prime. Because the width is smaller, you still have to do the 18 feet from the 0.6 of the building height. So we've eliminated 1 prime, and then lastly, if we go to 30 foot wide building, now you've done away with the zone 1 as well, because the width of the building is only large enough so that you have zone 2. So a lot of things we got to keep in mind is that when these layouts that we're looking at, it's going to be very much dependent on the height and the width of the building when we're determining this layout. Now let's talk about corners. So not all corners are going to require enhancements. So what do we mean by that? Well, first off, inside corners, according to ASCE 7-16, do not require corner enhancement. So we're all used to, you know, a nice, perfectly square at all the corners when it comes to what we're used to doing. Well, in this inside corner is not required. Number 2, outside corners with an offset less than 0.6 of the height. So if we go to the top of the building right here, we see this offset of 15 feet. Well, that's not equivalent to our 18 feet, which is 0.6 of the height. Therefore, we do not have an outside corner there or a zone 3 there because of if the offset is less than what we need to achieve for 0.6 of the height. The next one is the angle. Okay, so you know when we learn the angles in elementary school, anything greater than 135 degrees does not require corner enhancement. So let's give 2 examples for that. As you can see, this one, it's not your typical 90 degrees, but it's still less than 135 degrees. We will need to have zone 3 there. But if you look right above it, there's another one. This one is greater than 135 degrees, so therefore no zone 3 enhancements. So a lot of crazy stuff. So now, with that said, we're going to go to adhered and what that means. So what that means is we're looking at a lot of fasteners, right? So L shape is required at the corner, and you can see that there, okay? Then you can see the perimeter is going to match up with the width of the corner. And then what Wally and Chino are going to talk about is, hey, do we extend the boards over? Do we chalk the boards? Well, they're going to talk about that real quick. So I'm not going to spend a lot of time on that because they're going to go in more depth on that. But as you can see here, these boards extend into 2 zones. So what do we do there? Do we go higher? Do we cut the board? How do we do that? And they're going to talk about that more in depth as what makes the most sense in the field. And lastly, the length of the corner. Remember what Chino said. It's really easy if we keep that in mind is you know if you have the right dimensions, if those corners and those perimeters actually, the distance, the length of the corner matches up with where the zone 2 starts. Okay? So with that said, I know we went through a lot of stuff. If there's any questions, please put that in the chat box. And I'm going to turn it over to Chino and Wally so they can show us what it looks like to lay it out.
Okay, guys, so the drawing is all fine and dandy. I mean, if you're like me, you look at a drawing and go, what the hell is that? I want to see it laid out. So this is kind of what we came up with. Now, please don't critique our artist skills because we're not that good at it. But what we did, we kind of, if you guys, Ed, you want to zoom in on this right here? So here's our corner, just to give you guys an example. And this is almost to scale, almost I say, because we're not that good. So this is what our corner is going to be. So this equation for this mock-up actually worked out. Our corner had to be 20 foot long and 8 foot wide. So right here, this is a full board. So 8, 16, 20. Now the rest of this is our zone 2. So we're actually going to have to split a board. And if we come up here, we're going to be actually 20 feet up here, and we're 8 foot wide. So here we're going to have to split a board. So you guys are in the field and looking at this like, holy crap, how am I going to do this? I got snap lines and insulation. It's kind of mind-boggling at times. So it even gets even worse. Let's say you're working your way up this roof. Well, let's say I've got a full board here. So now I've got 4, 8, 12, 16, 18. I've got a half board up here. Something to always remember, guys, you can never go under that equation. You can go over, but you can never go under. So here you're going to have to split a board. So again, this is all up to you guys how you want to lay this roof out. And you can tell this looks really busy. I understand that. This is how many fasteners with the way this equation worked out for this mock-up. This is what our fastening pattern, how many screws in place we're going to need for each board.
So
Now,
pretty much right here, Wally, we're constantly splitting
boards all the way across this entire roof.
So once again, guys, like Wally's also talking about it, it all is going to depend on your guys out in the field. Because to them, it might be just simpler. You know what? I'm just going to not split it and go with that full board. It's just thinking outside, right?
Well, then it's going to throw your L off.
Throws the L off.
So then you look at, well, I'm supposed to have an L, but it doesn't look like
Yeah.
an L. But you went over.
You went over.
So, now again, guys, I kind of drew this up. Again, this is alternative for you guys installers out there. So, I didn't put the fasteners in here, but this is the scale. Let's say this is my corner. Here's zone 3, zone 2, and the rest is zone 1. So, again, we only needed a 20-foot long corner, right? So, you're thinking, well, this is adhered. Where's your stagger? Now, I'm going to say something here. You guys are all going to, I can just hear you guys screaming on the other end of your computers. You really, if you stagger off your bottom layer of your insulation, there is no reason to stagger your top layer. I can hear it now.
With GAF.
With GAF. I can hear it now. What? What are you talking about? I get it, guys. I was in the field for a lot of years. It's roofing 101. We've staggered insulation since Christ was a child. I understand
They know why they stagger.
Exactly. Good question. So I will put it out there. Give you guys a couple seconds. Why do you think we stagger insulation? Anybody got? Shout it out.
We can't shut it out. We want to hear them.
Oh, I'm sure they're screaming now because what do you mean stagger insulation? Well, stagger insulation. Give you guys a couple more seconds here. So, I've heard anything which people say it strengthens the roof.
Yeah. It locks it in.
The actual answer is we've always done it that way.
We've always done it that way.
And I ain't buying lunch.
Heat loss. You're
Heat
under
loss.
exactly thermal bridging. So, but if you stagger off your bottom layer, let's say if I'm starting my bottom layer here, if you can notice, this is a 2-foot board. It's not a full board. I will actually be staggered off that bottom layer. Again, this is just a suggestion for you guys in the field. Stagger off your bottom layer. Run your full 4x8 sheets. Now, am I longer? Sure, I'm long. I'm 24 feet this way, but I'm still 20 foot this way.
And we have our L.
And we have our L, if you will.
Once again, this is just for GAF, Wally, right?
GAF.
GAF is allowing this.
And tomorrow we're actually going over RhinoBond install, which this really plays a big role in.
Yes.
But again, it's going to be easier for you guys in the field to lay this out. Am I using more fasteners? Sure. But again, it's up for you guys to decide how you want to lay this out. Is it going to be easier for you guys in the field? Depends on your crew.
Yeah. Well, that's what I always looked at when I was a foreman, and then became the project managers. what could I do to make it easier for my guys where they're not cutting those corners?
Yeah.
Right? And if this is going to help them out, it's easier to understand this. This is the way I would go with it, right? Yeah.
So again, it's just an option for you guys in the field. We're not engineers. We're
trying to be. It ain't working out.
So hopefully that didn't confuse you guys too much. But again, just options for you guys in the field.
Well, unless there's some questions, I'm sure there's probably some confusion still out there. And so with that said, I think it's time to bring in our heavyweight superstar, super smart genius, Joan Crow. What do you guys think?
I thought you were going to say Dave Scott for a minute there. I got confused. Like, wait a minute, he's here? But yeah, Miss Joan Crow.
You are on, Miss Crow.
Again, you guys make me blush. So hold on. All right, let's share my screen. Hold on.
And so what's awesome about this is that Joan is actually going to run through a real building example with the uplift pressures. So something that, somebody in engineering or somebody super smart like Joan can figure out where, we want to just know, hey, how many fasteners do I need to put? So, Joan, I'm going to turn it over to you.
All right, everyone can see my screen, right?
Yes, ma'am.
All right, so I'm going to go over an adhered roof system. Again, we're going to use prescriptive enhancements. So I picked Chicago because that's where Wally, Chino, and I reside. I'm using Wally and Chino's example of a 30-foot tall building, and my dimensions are 100 foot by 100 foot. So again, this is where we have our membrane that is adhered to mechanically attached, and in my case, I picked a cover board and insulation. This is probably one of the most commonly used of our systems. But this is when you're relying on that mechanical attachment of the insulation for wind uplift. So the basic equation in simple terms for wind design is that you want the design wind loads. Those are the pressures that a designer, a structural engineer will calculate. It's like a prediction of what is going to happen to that building. Now, those values should be less than or equal to, excuse me, a roof system that has been tested. So, us manufacturers go test all these different assemblies and we see where they fail. And then the number that they fail out becomes the rating for that system. But this is the basic equation. You want to make sure those calculated values are less than or equal to what's been tested in a laboratory, because that's why we know where it's going to fail. So the question is, I know you guys wanted some numbers and where you get them, but unfortunately we can't. There's too many variables. There's two equations with 8 variables, 8 or 10 variables. But if there's a designer on board, it is required by code that they give you guys the wind data information. Okay, so it should be on their drawings and or specifications. If you do not see them, go back and yell at them and tell them to do their job. Again, if you need the quote out of the code, I can send that to you, but I constantly use that. In one of our other wind presentations, I always have that slide showing you where it is in the code. So if you don't have a designer on board, like in a re-roofing where unfortunately the contractor has to do some math, there are several options. There is RoofNav calculator. The only problem with RoofNav calculator is that you're going to get a little bit higher pressures because FM is an insurance company. So they kind of play a conservative side and they increase their pressures by a lot because they're an insurance company. They want to make sure that whatever their calculator determines is going to be a roof that stays on and stays stuck, right? So I tend to discourage using RoofNav, but if that's the only thing you have, that's the only thing you have. Another option is the National Roofing Contractors Association's online calculator called Roof Wind Designer. I helped develop that when I used to work at NRCA. There are limitations to it. It has to be a pretty simple building, but still it's better than nothing. And it was built step-by-step, simple instructions for contractors in mind. And it's up to 160-foot tall buildings, so you can use it for that. But pretty much the building's got to be a simple design. And then, of course, last but not least is you could hire an engineer to do your numbers, which the world's getting so complicated, we're almost headed toward that. So I play an engineer, I don't play one on TV, but I do I am able to run some calculations. So for our building in Chicago, I determined what the pressures would be. And for prescriptive enhancements, you always use the pressures in zone 1 as your basis. Okay, so for my building, my 30-foot tall building in Chicago, an office building, a very simple category 2 building, I got 47 pounds per square foot. And that's what we're going to use to select a rated system. So the question always comes up, where do I find a rated system? Well, believe it or not, there are actually 6 sources for finding WIN-rated roof systems. They're called listing services, and these are the 6, but the most popular one is definitely RoofNav, right? The second one, which I recommend people using, unfortunately doesn't have as many listings as RoofNav, but still it's so user-friendly. It's by SPRI, the Single Ply Roofing Industry organization, and it's DORA, not the Explorer. It's the Directory of Roofing Assemblies. And then followed by UL's Product IQ, and then what I call the 3 Gulf State listing services, which for you guys in the South or on the Gulf Coast, you probably use those more. I'm not going to go over those. But just realize that you are not limited to RoofNav to find your roof assemblies, okay? So with that in mind, because I do have a slight hatred for FM, I'm going to use DORA in this example. And you can see here's a screenshot of the interface where you can simply pick the manufacturer. I'm picking TPO for my example, and then simply you could just say, I'm looking for a 60 pounds per square foot assembly. So if you heard me yesterday, rated roof systems start at 60 pounds per square foot and increase in 50 pounds per square foot. So DORA, similar to RoofNav, will start at 60, and you'll see it in the 15 pound per square foot increments. So 60, 75, 90, 105, 120, 135, etc. So let's go back to the design values I came up with. So it looks like we're going to be using 60 because 60 is greater than 47 pounds per square foot, and 60 is the lowest we can go with, right? So here's where we end up. So I selected one of GAF's assemblies, 26762. But basically, as you can see, the wind uplift is 60 pounds per square foot. And if you go to the securement information, you'll see something that says 1 fastener for every 4 square feet. So for a 4x8 board, you're going to need 8 fasteners per board for a 60 pounds per square foot roof. And again, this is for an adhered TPO. The top layer is like a dense deck, and then under that is polyiso attached to a steel deck. So here's Wally and Chino's example roof, where we're showing in the field, for the 2 field zones, field 1 and 1 prime, we're going to use 8 fasteners per board in the center. Now we're going to do a prescriptive enhancement in zones 2 and 3, the perimeters and corners, and we're going to use something called FM1-29, which is a loss prevention data sheet, if those of you who are not familiar with it. And GAF uses what's in that guide as our the basis of our logic in treating perimeters and corners. Okay. Sorry guys, more math. So FM1-29 says, in the perimeter, you cannot exceed 67% of the, quote, fastener area of what's used in zone 1. So if we recall, zone 1 uses 4 square feet. 67% of 4 square feet is 2.68 square feet. So our board, we're using 4x8 boards, which is 32 square feet. So you divide it by 2.68, and that ends up to approximately 12 fasteners per board. For corners, 1-29 says you cannot exceed 50% of the, quote, fastener area of zone 1. Again, zone 1 is 4 square feet. So zone 3, 50% of that is 2 square feet. So that was easy math. And we end up with 16 fasteners per board. Easy peasy, right? So prescriptive enhancements are a way to, it's like a rule of thumb almost. We're prescribing a way to increase the fasteners without having to do more, at least do more intensive calculations to determine how many fasteners in the perimeters and corners. And as Wally mentioned, if a board crosses that borderline of the L, you have the option to either just fasten to the higher number of fasteners, or if the board kind of conveniently splits in half, you can do one half one way and do the other half the other way. But anyway, so this is an example of a 1-60, all right, 60 PSF design roof with an adhered system. So that's all I have.
So again, we're just giving them another way to fasten those boards to.
And after all that calculations,
I was like,
please
what?
don't kill us again.
Yes.
That's industry, guys. It's not GAF, but
We're trying to make it simpler for you guys to understand, basically.
so Miss Jones, there's no way heck we could have done this.
No.
We would have been like a bunch of gorillas.
But it was definitely fun working with these guys. So any questions, give us a holler.
Thank you,
Thank
Miss
you, Joe.
Jones. See, look at McCabe's on mute again. Look at him. He's talking. He's
Time,
on mute.
every time.
Okay, so a couple key takeaways. ASCE 7-16. Remember the formula. Zone 3, corner length, 0.6 of the height. 0.2 of the height is your corner width for zone 3. Zone 2, perimeter width, is going to be 0.6 of the height. And a couple other nuances: parapet wall greater than 3 feet, no corner enhancement, no inside corners, no outside corners if offset is less than 0.6 of the height. And last but not least, no outside corners if greater than 135 degrees. So just a couple, takeaways that you could use, especially on the install. Now, unfortunately, we wish we could give you, all the fastening and all the cool stuff that Joan just showed you, but, well, that stuff is going to have to be designed by what's being said. So, with that said, we're going to leave it open to any questions. Now, strongly recommend that you guys check out tomorrow with RhinoBond, because not only are we going to be talking about RhinoBond, but we're also going to be talking about when we use different attachment systems or hybrid systems for our attachment. So check that out. It's going to be a really good one, because there's a lot of savings that you can do when we do approach that.
And Steven, just real quick as well, is we did do mechanically attached yesterday. There was some different ways on how to install it. RhinoBond, same way, different ways you can install it. Here, it's actually, technically, there's only one way, right?
Other than eliminating, utilizing.
Yes, not staggering, but
Staggering.
so it was less content here compared to yesterday and tomorrow.
You're still the fasteners for here. It is what it is.
It is what it is. Yeah.
I think there was a question in there. Something about adhesive.
When and why will remaining states adopt ASCE 7-16? So, Greg, that is kind of like looking into the crystal ball. But I mean, if us guys, Gino, Wally, and I, we kind of discussed it. You're probably going to see this as mainstream probably within 3 years. You're going to see a lot more taking the ASCE 7-16, unless something reverses. Because as Wally pointed out, roofs are not blowing off because of the installation to ASCE 7-10 standards. It's because of faulty installation methods that they're blowing off. So, with that said, maybe it'll be reversed, but right now it's going to continue to grow. With that said, and then Chris said, "Are there enhancements of the adhesives if used for insulation?" So that is.
Yeah, you want me to take it?
Sure.
Yes.
Okay, so yes, there would be. So if you're using low-rise foam, you're going to be using the ribbon pattern. So like 12 inches on center might be for a 1 dash. Don't quote me on this, but say, for example, if a 1-60 requires ribbons at 12 inches on center, then yeah, you're going to reduce it to 8 inches maybe in the perimeter and 6-inch spacing at the corners. So, but yes, it is applicable to the adhesive beads.
Thank you, Joan. And I think that answers most of the questions right now. I just put in the chat box a survey, so we really appreciate if you could fill it out. This is actually Chino's survey, because he was the mastermind behind this training. So,
Don't blame me for this.
So with that said, any training credits and certificates. So if you're a Master Elite, Master Select, Master Contractor, and you want your training credits, this is the way to go. If you want a certificate saying, hey, I've been, factory trained, I've been trained by GAF to at least from a 30,000 foot view and kind of like the installation perspective, you're going to get the certificate from that. So the 3 ways to register. Number 1 is, and let me get that up on the screen for you, is hold up your camera browser to the screen and to the QR code. And if you're using an Apple phone, a link will pop up. Just click on that link. Option number 2 is going to be the QR code, which I'm going to be adding. And the third option is sending a text message. So I've got those in there right now in the chat box. So you can send a text message to 56512, and then in the text box, capital S, capital M, DSNNX. So if you type in that, that will bring you to the link as well, or just click on that URL link right there. And one thing I did miss, if you have an Android phone and you hold up your camera browser to it, it may not pop up. You may have to take a picture of it and actually add it to your QR reader if you're using an Android phone. Now, once you get to the registration page, a couple things just to cover there. Your company name. So if you're trying to get training credits for your company, GAF provides training excellence awards for, once again, those Master, Master Select, Master Elite contractors. Then you'll have to get the company name correct. So as you start entering the company name, let it auto-populate and then select the one that's yours. If you just fill in whatever name, you may not get the training credits because it's got to recognize what you registered with GAF. So you can also find that in your contractor portal to find out what your name is. Number 2 is your first name and last name. Well, actually, let me go back. If you're not a Master Elite, Master Select, or Master Contractor, type in your company name as you see fit. Just type it in its entirety, and that's what's going to show up on your certificate. Now, your first name, last name, make sure you double check it. We don't want a Bateman turn into Batman. Autocorrect does some funky stuff sometimes. So be cognizant of it. And last but not least, your email. I get probably about 1 or 2 people all the time that will not add their email. If you do not add your email, you won't get the training credits and you won't get the certificate. So please, it's not for spamming purposes, it's so you can get that training certificate. Now, once you get that registered, you have this page that pops up. The video showing the manuals, courses, and also contact us. So if you're new to GAF and you're like, man, I would like to know more stuff, you can click on that link and then type in the zip code. The residential, commercial, and our coatings salesmen or territory managers will come up. Coding guys are actually called TSRs, technical service representatives. So they will get your local contact for you. The other one to point out is courses. So we're going to have the RhinoBond of this tomorrow. And we also have IBC and IECC this afternoon and tomorrow afternoon. So come back to that. We look forward to seeing you there. Now, the last one is the learning portal. A lot of good stuff. So you'll have videos of the shingle whisperers installing a power fan. You've got the weapons of mass destruction showing live videos of installation. So some great stuff there. Just go to www.gaf.com/learning. So we have a lot of pre-recorded webinars on there. We are not going to be having these recorded and put into the learning portal. GAF is going to come out with another training on this to be put in the learning portal and recorded so you can review that. But right now we're just looking at the 30,000 foot view. So stay tuned for that. And with that said, this concludes our training. So thank you for joining us today. We got Chino, we got Wally, and myself. And if you got any other questions, we'll stay on a little bit longer.
Thank you, everyone.